Good. So I want to give you guys a vision of something that's really emerging today. And I guess I want to kind of challenge you to think about your world 5 or 10 years from now and where machine learning is going. So let's start by asking, how many of you are using machine learning for some kind of customer analysis or analysis of humans in some way? Okay, that's a big group. Those of you in the front, you should look back. It's a big group. How many are you in banking or some kind of financial analysis? Just a couple. Healthcare? Healthcare? So good. Think about for a moment, what is the purpose of the machine learning that you're doing? Is it saving lives? Is it solving the great complex problems of the world? Or is it helping you to learn more about customers so that your company can make more money and be more effectively competitive? What's really exciting is it turns out that there's an emerging discipline that allows us to use machine learning to solve thousands of new use cases that it's not being used for today. And the reason we're not using it for these use cases today is these use cases are a little harder. They're situations where we don't have massive amounts of historical data. We don't have necessarily data about all the links in the system. We have to actually use humans for their expertise in some cases because they involve fairly complex systems that often are brand new because the world is changing in many domains very, very rapidly. So I'm very excited to give you guys a view of the future and to tell you how machine learning is going to be used 5 or 10 years from now. So I'm a little bit of an iconoclast. I was a data scientist. I built some of the early machine learning transfer algorithms and neural nets. And in 2008, I decided to start a company. And I knew there was this thing where if you just build technology and expect people to come, well, that doesn't work. So I spent about 1.5 years actually talking to people. And I asked a pretty broad question. I said, if technology could solve just one problem for you that it doesn't solve today, then what would that problem be? What would it solve? And I'd had relationships kind of at the C level, at senior executives in charge of billion and trillion dollar companies within governments. And I said, look, technology's doing all this great stuff. Where's the gap? Where do you need it? And an answer came back pretty clearly where they said, there's massive amounts of data out there, there's machine learning, there's advanced technology, but it's not getting used for the most important decisions. So, for instance, you're at a board meeting of $1 trillion mobile phone company, and you're sitting around the table and you kind of pore over the charts and the graphs and the pie charts. And the other day I saw a presentation, 300 slides, all the data, right? And then somehow you look at that data together with the other executives, try to upload that data into your brain, and then make a decision that could really be make or break for your company. So think about that scenario. What are we doing? We're analyzing data, we're getting great machine learning, and then we're trusting kind of the human brain to compile it together with the decisions in order to determine how it's going to impact our outcomes. What's wrong with that picture? We're not really using computers as best we could. And so in this 1.5 years of research I did, I learned there was a gap, that there's decision makers who are quite frustrated. And I swear, I talked to hundreds and hundreds of people, and very rarely did they talk about graph analysis or support vector machines. Instead, they said, look, we're making a bet on our company that's going to cost us millions of dollars, and we have this sense that there's this treasure trove of data and evidence out there, but it's absolutely overwhelming. It is making our heads explode. And the data guys similarly say we have all this great data and it's not being used. There is a gap, you guys, between many, many use cases, whether we're trying to solve Ebola in Africa or reduce conflict in the Middle East or simply do government budgeting in the United States. Use case after use case after use case, the data is getting underutilized. It's latent, it's there, there's value there, but it's not getting used. So we set out as we started the company to say, okay, how do we fill that gap? And what was really awesome, there was a few kind of discovery moments, and one of them was that this question is the key unanswered question that machine learning is not answering for us. And it's what will be the impact of today's decision tomorrow? And as we looked at all these hundreds of, we interviewed and transcribed and analyzed hundreds of decisions, and I assume there's hundreds of thousands that we didn't talk about, we realized that what people are doing, it's very common. It's just like in software, we have while loops and if statements, and there's common structures that we've converged upon that seem to support all software, whether it's whatever language you're in. Unless you're in Lisp, in which case it gets a little weird. There's also a common structure to how people think about complex situations. And the structure is, I'm going to make a decision today. It's going to ripple through some system, which, by the way, is a complex system with feedback loops and strange, virtuous and negative feedback cycles and interesting dynamics. And then eventually that's going to produce some outcome. We'll either save lives, we'll save money, we'll make money, we'll cure a disease. But the question that folks are facing that is not getting solved by the existing systems is, if I make that decision, as it interacts with a changing world, how does that ultimately impact the things that I care about? And that's the question that's unanswered right now. So we have, conflict issues where we've got water and food and climate change, and the Millennium Project has got this, they've identified kind of the great challenges facing the human race over the next few years. And you can see we've got clean water, and then the line from clean water to the status of women says there's a link there. So if you make a decision about the status of women, it's going to impact clean water, and that's going to impact the rich-poor gap, and that's going to impact peace and conflict. And so there's these very complex interdependencies between these realms that we usually decompose into pieces. And so that's why the Millennium Project says, number 9, the capacity to decide is critical. We need to know, as we make a decision, how it's going to have this ripple effect through a very complex world. You guys are all asking, what the heck does this have to do with machine learning? We're getting there, trust me. It's critical. It's absolutely essential. Okay, so I pulled this graphic up yesterday from TIBCO. They said, look, the top big data use cases, customer analytics, customer experience analytics, a little bit down there in drug discovery. Really, what we're doing here is solving a pretty narrow set of use cases. I think if we were to extend this study and ask the people in this room, we'd probably get, under a dozen use cases that accounted for 80% of you guys who are here. And these folks who are looking over the charts and are trying to make decisions that affect conflict in human lives, they're asking you, isn't there a better way? I'm making big decisions. Isn't there a better way to structure all this data and to use machine learning and all these other advanced technologies to get the most value out of these systems? And so that's what I'm going to talk about. There's thousands of new use cases if you guys want to take it on. It's pretty exciting. So let's just draw a distinction. I'm going to call these kinds of decisions big decisions. Big decisions, according to PricewaterhouseCoopers, a typical executive makes these, I think it's about 3 a month. Big decisions that require a lot of human input. You usually want all the data you can get. And again, you look at these great data visualizations and then you upload them into your head. Imagine, given this data, how my decisions are going to play out, and then you look at those outcomes. In contrast, we have the use cases that you guys are mostly doing, where they're highly automated, they're micro decisions, they're done, every few milliseconds in Netflix when we make a recommendation, and there's not a human in the loop. And so one of the essences of the things that I'm talking about here is we have systems that have humans in the loop, and that's hard, but it's not impossible, and there's some solutions that are emerging. So this is kind of the picture of the story I've been telling for a while here. So we've done a great job with data. Congratulations. We can process and store data faster than we ever have. Moore's law means that we can analyze it, and that's just going to keep getting better. But again, we have this real bottleneck where we look at the data, and then, seriously, as I talk to hundreds of people who have some of the greatest influences in the world, they're not using that data the best way they possibly could, and it's pretty overwhelming. So how can we use computer power to solve that? How can we start to get these massive banks of systems to go beyond just the data to systems analysis? And systems analysis is just, as I make a decision, how does that impact my outcomes as it plays out over time? And then how does that ultimately impact my decision? So this is a graph I'll come back to in a little bit, but it's so important that I'm going to show it at least 2 times in this talk. There's another kind of epiphany we had after we discovered that there's this common frustration with the data and machine learning stack, and that there's this one question that everybody's trying to answer: what's the impact of today's decision on the future? We kind of dug into that, and we realized that just as coding languages have a common set of constructs, decisions also have a common set of constructs, and it looks like there's only about 5 or 6. So on the left-hand side, we have decision levers. Those are the things you can change: the price I can charge, the country in which I launch my product, whether or not to acquire a new company, all of those big decisions in which, boards of directors get around and debate. On the right-hand side, we have outcomes: lives saved, increases in revenues, reduction in disease, anything that you're ultimately trying to achieve. In red at the top, we have what are called externals. These are things that we can't affect directly, but represent our scenario or our situation, and that marry together with the decisions in order to ultimately produce the outcomes. And the intermediates is just kind of a cloudy, fudgy way of talking about the fact that those things marry together. And we'll see some examples of this in a minute. But ultimately, what's interesting here is the world, there's a whole bunch of data that in a lot of different domains, I don't know if it's due to globalization or what, things are changing faster than they ever did before. Used to be you could make a business decision and it was pretty good and it would last a year, but these days things change. And so the decision you make this week, which achieves a certain outcome, won't achieve that same outcome next week because your situational variables have shifted. And so this is really a navigational structure. I'm making a decision in some context, it's producing some result. The context changes, now I need to adjust my decision. It's like going from steering the Titanic to steering a whitewater rapid boat, where you have to pay attention to the currents and steer left and steer right depending on your environment. So we really need a much more rapid response kind of situation. But again, what's exciting here is every decision is made up of these components, and this is a complex systems model. Anybody do complex systems analysis with feedback loops and stuff like that? I see one hand. That's a really important area for you guys to start getting into. And here's where machine learning fits in. Each one of those links can be informed by data, and each one of those links often needs machine learning from historical data to get it started, and then we need an adaptive, predictive approach to update that link as we go forward over time. Okay, so we can't do these causal models without good machine learning to get an analytic, whether it's a simple regression or something linear or a graph analytic, that if we're in a social situation, each one of those links between cause and effect can depend on machine learning. Sometimes it's just an equation like x plus y equals z. So before I go any further, I want to show you an example of one of these things in action. So this is an interactive decision model. So levers on the left-hand side, outcomes on the right-hand side. So imagine you're the board of directors of some widget manufacturing company. And life is going along okay, you've got some production, you've got some net revenue. And this is kind of a slice through how you think about your world, right? You've got your profits on your right there. Your net revenue is made out of gross revenue and costs. Your costs partly depend on production costs. So this is kind of just a version of how you might think about the world. And then what happens is life becomes more complex. Suddenly, we're faced with a carbon tax. And I need my mouse, and I don't see it. That's okay. Suddenly, we're faced with a carbon tax. And what happens is now we've got emissions coming out of our plant, right? And for every amount of CO2 coming out of our plant, we have to pay a carbon tax, which adds to our costs. And so now we've got a new decision. Are we going to finance some new plant that might be low emissions? And when we do that, we're going to do it in the face of some particular interest rate. So the question is, what should my production volume be? How much of the old polluting plant should I keep online? And how much new plant should I keep online? And there's a feedback loop here too, where if I have low carbon quantity, I can market myself as a green company. This is kind of the Starbucks effect, where people will pay more for the same commodity because they like you. And so you can stretch your margins, and then if you reinvest that back, as Starbucks does in health care for its employees and educational programs for its employees, and you reinvest that back into customer care, you get this positive feedback loop going. So if I market about carbon quantity, my goal here is to get this revenue number from negative, the net revenue number from the negative to the positive territory. So the question is, where do I set my levers, given certain assumptions about the interest rate I'll have to pay in order to finance my equipment, in order to get that to raise up? So this is a decision model where we have levers that lead to outcomes. It's got some feedback effects in it. And each one of those links can be learned over time as we gather data as the system moves forward. And I've been playing with a new version of this model, which is an online version. This is on a website. And basically here, I had fun with the particle engine and the smoke. But basically, what we are is we're living in a highly interactive world in which we're making these same sort of decisions, and we're observing their outcomes as they play out over time. So that's really the essence of what I'm talking about. Just a little bit more, and then I'll wrap up. This is not just me talking. This is something that's emerging really all over the place. PricewaterhouseCoopers has identified this whole unmet realm of big decisions, and most companies don't believe that they have the full support that they need for these multi-billion or trillion-dollar decisions. There's a bunch of folks talking about factivism, using the data stack in order to support, important issues in the developing world in particular. These are a whole bunch of Forbes 400 billionaires who went to Liberia last year, which was pretty exciting, and are trying to use data and machine learning to make some great decisions there. PricewaterhouseCoopers, Accenture says data is really underutilized. Another PwC report, another report about telecom. AIG has a 140-person group, which does only this. And here's something else. I'm talking about technology today, but we really need people in this loop too. So Adam Bryce, which is an executive search firm, is saying we're seeing increasing demand for a C-level executive who's responsible for this very thing, who understands how data and machine learning supports business decisions. This might end up as a role for the CIO. It might be a role for the CDO, or you guys may become chief decision officers, because this is a really important problem to start solving. Harvard Business Review, there's new companies, Informed Decisions, is pioneering this decision intelligence stuff. Absolute Data that I just ran into about a week ago, also a decision engineering company doing this same idea. And so really, this is kind of the future. Big data is important, and we talked a little bit earlier about models versus data. Well, obviously, both of them are going to be important. But as we move forward, I'll challenge you guys to look at your data stacks, to look at your machine learning capabilities, and ask, what are the big decisions that you can help to affect? How can we go beyond today's use cases and start to structure our decisions to use human expertise when data is not available, and be able to run complex systems models to understand how today's decisions affect the future? Thank you very much.